Hi, fellow travelers. If you're traveling anywhere outside the United States, you will come across elements of the metric system that includes Celsius, degrees, or centigrade for temperature. In this video, I'll show you two ways to deal with the situation: a quick conversion that gives you an approximate, reasonably approximate Celsius degree result within seconds with a little bit of mental math. And I've heard it from an 8-year-old kid who said, "Hey, you want to hear a neat math trick that I learned from grandpa?" So I'm going to start with that one. And of course, outside of this, you can look at a conversion chart, or you can look at an online converter and plug in any number here and get an answer in seconds. But I'm going to start with this one. Sorry about that. So this is how it goes. You take the Fahrenheit degrees, you subtract from it 30, and then what you have left, then divide that by 2. Because this is, you read it from left to right, and there's order of operations here. Really, this should be in a bracket to ensure that this subtraction gets done first. Because BEDMAS or PEMDAS, whatever rules, would tell you that you divide first. No. Just do it from left to right here, so you're subtracting first. And that's how you get Celsius degrees. This works reasonably well here in an Excel spreadsheet. I can show you with a couple of Fahrenheit numbers. So if you have 0 degrees Fahrenheit, subtract 30 from it, so that's negative 30, and divide negative 30 by 2, that's going to be negative 15, and that's reasonably approximate. 50 minus 30, sorry about the camera focusing here, 50 minus the 30 is 20, divide 20 by 2 is 10. So there's your next answer here. And the last one here, 100 minus 30 is 70, divided by 2 is 35. So there. I do want to point out that these numbers here are forming a linear equation as x and y values, and can be plotted. When they are plotted, they are going to look like this. So this is the same equation here, except this one starts with c equals instead of c being here, because it's just the same thing, just different ways of printing the same thing. So c equals, and I can even print it this way. Sometimes you can come across it this way. If I put a fraction here, put 2 there, the division goes there, and f minus 30 goes in the numerator. So you start with the subtraction and then divide by 2 to get your Celsius degrees. Either which way, this can be written as y equals x minus 30, like so. And this can be also written this way, divided by 2, or with this fraction format, or even this way. Insert the fraction here, and the fraction will be that divide by 2 is that fraction, 1 over 2x, but it's not quite x, it's x minus 30, something like that. Okay, so these are all different ways of writing the same thing. So you subtract 30 first, and then you divide by 2 to get your Celsius degrees. So the equation looks like this. It's printed here in this way. There's the 1 over 2 or divided by 2 idea, and there's the subtraction idea there, and it forms a straight line. This is a linear equation, and if we find 50 on it, here is 50. The horizontal axis is the Fahrenheit degrees, and the vertical axis up and down, that's the Celsius degrees. So at 50, take away 30, that's 20, divided by 2, 10 there. At 50 we are at 10. There, you get the idea. Okay, and at 100 minus 30 is 70, so there is 35 there. Oops, there, spot on. Okay, so that's how this equation looks like and works like. However, this is not the actual equation. It's slightly inaccurate. The real equation is coming up here. It's looking like this. It's not subtract 30, it says subtract 32. I'm gonna fix that one there, like so. It says equation says subtract 32 instead of 30, and it's not divided by 2, and so this fraction is not 1 over 2 here, it's 5 over 9. I wanted to put this fraction in here because there is a fraction and it's 1 over 9, oh sorry, 5 over 9, not 1 over 2. So the same equation can be reprinted for graphing as follows: y equals 5 over 9, open bracket, x minus 32. There, and you can see immediately that there's a difference between the two graphs. So this one here, the red one is the actual one and the green is the approximate. You can see that within reason here between 40 and 50 Fahrenheit, the difference between the two is negligible, or depending on the range of things you need between, I don't know, 10 Fahrenheit and 100 Fahrenheit, the range here is pretty close, and then they start to differ. So for cooking temperatures 300, 375, whatever, 350 for the oven. The difference here now in Celsius readings is let's see, just zoom in or click on it, 160 versus 176. So now the difference here is like 15 degrees. So depending on the kind of accuracy you need, you can see that the estimation works, but it's again only an estimate. So this is the actual equation here. Can also be printed, like I said, in this linear algebra or graphing from grade 10 way. And so that's again, that's the quick way here, and it's reasonably accurate.